All right, so today we're going to talk a little bit about what is mass. What makes things heavy? What gives them that weight? Um, those little particles that we've been talking about have something to do with it. But what exactly makes something heavier than another object? Why is a rock so heavy and a feather so light? Well, it all comes down to the fact that mass is the amount of matter or stuff in an object. Matter is all those little tiny particles that we've been talking about in class. So the more matter, the more particles that an object has, the heavier they are. Each particle has a tiny bit of mass. And the more particles you add, the heavier the object will get. So if you're looking at two objects, such as a golf ball and a ping pong ball, which one would have more mass? Hopefully you're thinking it would be the golf ball. So then what do we know about the particles in those two objects? If this golf ball has more mass and it's the same size as this ping pong ball, which one has more particles? Again, it should be the golf ball. The golf ball is heavier, has more mass, therefore it has more particles inside of it. What else do we know about mass? Well, we know that we use grams to measure mass, and in chemistry we'll be using grams a lot this year. We know that to measure it we use a balance with a fulcrum, and we're going to talk a little bit about what that means in a minute here. We also can use an electronic balance to speed the process up when measuring mass. Here is a picture of the balance with a fulcrum. The fulcrum is like a teeter-totter. Teeter-totter has a fulcrum right in the middle, and that's what everything balances on. This is sort of a lopsided teeter-totter. So here's your fulcrum, and here's one half of the teeter-totter, and here's the other half of the teeter-totter. Now we call it a balance because we want the stuff on this half of the teeter-totter to balance out with the stuff on this half of the teeter-totter, so we can get it to level out and get this end to line up with the line that's here, and that tells us that both sides are balanced. We place our object on this side of the teeter-totter, and we're going to use these sliders, these different massed weights here that we will move around to create different masses on this side. Then when we get these masses to match up with the mass of this, and we'll know that when it balances and lines up here, we know that whatever mass is shown here is going to be the mass of the object over here. Now what's weight? Weight is a little bit different than mass. Here on Earth, they're the same thing, which is why a lot of times we interchange the words, but technically there's a little bit of difference, okay? It's because weight depends on gravity. So if you have a different gravity, you're actually going to have a different weight. We have different gravities. In order to get that, you got to leave Earth. That's why weight and mass are the same on Earth. But if you leave Earth, your weight will change. Your mass will not. So typically, a typical average human being on Earth weighs about 150 pounds. If they head to Mercury, because Mercury has a lot less gravity, they'll weigh only 57 pounds. If you tried to travel to the sun, you would weigh over 4,000 pounds. So depending on how strong that gravity is, it's going to pull you stronger towards the surface and change your weight. We measure weight in newtons because it's actually a force. And because weight is slightly different than mass, we have to measure it differently as well. So we use what we call a spring scale for all you fishermen out there. This is a spring scale. So you hang your fish on the hook on the end, and gravity pulls the fish down, which therefore pulls the spring and tells you how much that fish weighs. Here is me. I love to fish. There's a big fish, the biggest fish I ever caught. Pure luck, no skill involved. So, you have mass, you have weight. They have a couple of things in common and a couple of things that are different. We're not going to go over these together, but you should make sure you understand this chart and these features as well. Here is the balance again that we had mentioned for measuring mass. This balance similar to the one that I showed you earlier in the picture, except for instead of the pan for measuring being up here, it's just hanging down to give you a little bit more room. So we need to be familiar with the different parts on this balance. One thing that we'll be referring to are the beams. This is a 4-beam balance, so the straight metal rods coming across here, and they'll be numbered with different masses, are called the beams. We'll be using a pan here, and the pan is where you're going to put the object that you want to mass. The riders are the different sized weights that that sit right on those beams, and the further you slide them out, the more effect they'll have on this balance, so the more mass that they will be balancing with. And you have to make sure with these that you get them, there's little notches on the top of these beams. You got to make sure that you notch those in so that you're getting an accurate reading. We have a pointer here, and that pointer needs to line up with a line on the other half here. Here's your pointer, here's the line it needs to line up with, and when those two things line up, you know that the mass here is balanced with the mass of the riders on this side. You have to make sure that your balance is calibrated, and we do that using our adjustment screw, which is always found over here. Now, how to read them. For these examples, I have for you a triple beam balance, so only 3 beams instead of 4 coming across. So on this balance, the pan would be over here, and we would line up our scale and our pointer over here to make sure that everything is balanced. Once you have moved the sliders over, and you've gotten them into these little notches that I mentioned before, and you have balanced everything out, all you need to do at that point is to add up the 3 riders, and you'll get your total mass. So here we can see on this rider we have 300 grams being shown. Here we have 50 grams being shown, and here it looks like about 7.3 or so. It's a little hard to read up in there. Each one of these little lines is 1/10 of a gram. So 300 plus 50 plus 7.3 would give us 357.3. Right on. All right. Looking here, we have a rider sitting at 50, and we have a rider sitting at 3, and looks like 3.9, just short of 4. So if you add 3.9 to 50, you get 53.9, which is the answer to this one. And our last example here, we have a rider at 400, and we have a rider at, looks like about 5.6. So our answer, if you add 400 to 5.6, is 405.6. And that one's kind of in between the two lines, so we gave you a little room for error. Go ahead and try these ones on your own. Pause the video for a moment. And then when you're finished trying them, you can unpause the video and check your answers.